All right. So, on example 8, we're going to talk about geometry. Geometry part here is that we're dealing with a hypotenuse of a right triangle, right? So the first thing we're going to do is draw our right triangle. Maybe one day the makers of PowerPoint will create a drawing tool so that my drawings would be a little prettier. But until then, I digress. Okay. It says that the hypotenuse is 6 inches more than the shorter leg. So I'm going to let this be my hypotenuse equals. And I've been told that my S's look like 5. So to represent my shorter leg, I'm just going to use X. Is that okay? So we're going to do it's 6 inches more than the shorter leg. So I'm going to let this be my shorter leg. Okay. And the next thing it tells me is the longer leg is 3 inches more than the shorter leg. And again, we're going to let X be our shorter leg. So the longer leg, L, equals 3 plus X. Could I have written them as X plus 6 and X plus 3? Yeah, because it doesn't matter. All right. It says find the lengths of all 3 sides. Okay. The key word here is that this is a right triangle. And there is a very special formula that we're supposed to use for right triangles. Does anyone know what that very special formula is? That's it. A squared plus B squared equals C squared. Where A and B are your legs and C is your hypotenuse. Do we have that information? We do. So we're going to plug this in. So for our A, we'll let it be our X. For our B, that's going to be our 3 plus X. And then for our C, that's going to be our hypotenuse, 6 plus X. And we're going to plug said values into the equation. Okay, so we're going to plug everything in. So A is X squared plus B, which is 3 plus X squared, equals C, which is 6 plus X squared. How are we feeling? Okay, so now I've plugged everything in, and my goal is to simplify and get one side equal to 0. So in order to do that, we're going to have to use all of our math knowledge and skills that we have. So first off, we have X squared is going to just say X squared. What does it mean when you have 3 plus X to the second power? There's 2 of them. So it's 3 plus X times 3 plus X. You cannot distribute the power over addition. And the same thing is going to go for 6 plus X. So it's 6 plus X times 6 plus X. And now we're going to go ahead and distribute. Distribution, aka time to FOIL, right? So we have X squared plus 3 times 3 is 3 times 3 is what? 9. Plus 3 times X. And then, so all I did was 3 times 3. 3 times X. Then the inside, X times 3 is 3X. And X times X is X squared. And we're going to repeat that same process on the other side. 6 times 6 is 36. 6 times X is 6X. X times 6 is 6X. And X times X is X squared. Okay, what makes equations beautiful is that the goal is for them to stay balanced. But if they have the same thing on both sides, they eliminate, right? So notice that we have an X squared and a X squared. So guess what they get to do? Go bye-bye. What does 3X and 3X make? 6X. So guess what I get to do? I get to cancel out the 3X and cancel out a 6X. So I've already simplified some, and now we're left with X squared plus 9 equals 36 plus 6X. Okay, I'm going to stop here and let you finish it. Find the measurement of my short leg. All you have left to do is get one side equal to 0 in the factor. All right, so first thing you should have did here was to get one side equal to 0. In order to make that possible, we would have had to subtract 36 and subtract 6x, right? So I'm going to move up here so I can have more space. So once you did that, you should have been left with x squared. And then you would have been left with minus 6x minus 27 equals 0. So all you're left asking yourself is what multiplies to give you negative 27, but adds to give you negative 6. And the numbers would have been x minus 9 and x plus 3 equals 0. So therefore, your x would have to equal positive 9 or negative 3. Well, can you have a negative measurement? No. So that means our short leg is how long? 9 inches. So if the short leg is 9, what does that make the hypotenuse? 6 plus 9, which is 15 inches. And then 9 plus 3 is 12 inches. So that's what the three sides of the triangle would have been. Okay? And we know that we satisfied it being a right triangle because we use a squared plus b squared equals c squared, which is only rule for triangles. And that concludes your 3B.6 notes.